In this video, we will see the next mechanism related to stack, and that is nothing but implementation of a stack using a linked list. In the previous video session, we have seen how to create a static stack, means how to create a stack mechanism using the array. Now, there were some drawback associated with this static mechanism. So, in this session, we will cover how to use the linked list to overcome the static stack limitations. Array implementation has certain limitations such as stack cannot grow or shrink during the execution of a program. For example, we have allocated only memory for 5 elements, okay, 2, 3, 4, 5. Then, at the time of execution, you cannot minimize it to the means you cannot shrink it or you cannot grow it like means you have no any access to increase the stack or decrease the stack using the time of execution. So this is one bigger drawback associated with the static stack implementation. To overcome this, we have to use the linked list for the stack implementation. Again, there is the one limitation, that is, for example, if you are using the static stack, means fixed stack, then there is only one top is present, and according to that, only elements with this top are carry forward or backward. Means elements are inserted from the same end and deleted from the same end. So there may be a chances of a traffic jam. If you are allocating the memory, like you are allocating the memory for such 5 elements, if there are only 2 places occupied by the program, then these 3 places will be in no use, and means this is the wastage of the memory. So there are such lots of disadvantages associated with the static stack implementation. To overcome this, we have to use the dynamic stack implementation, and that is with the help of a linked list. How to use? For example, we have to insert 3 elements into the array. That is, for example, 3 elements into the stack C, B, A. Why I am writing it like this? If I am writing A here, B here, and C here, then A will be shifted to the last position and keep out from that means taken out from that stack at the last. So it will be at the last position. To maintain the order, like after deleting A, B, C, I am writing like C, B, A. How to use the linked list? For that, we have to create a node, like a linked list node of a stack, and that is means which is the basic data structure of a stack in terms of a linked list. That is, for example, we have to create the struct node, that is representation of a stack. We have to take 2 points, that is data and the next node. So integer type data of size max. Okay. Then we have to take like for this max we can define like hash define max, for example 20. You can specify here your own values. Then there will be a node structure like struct node star next, okay, and completion and semicolon. So this is the same node structure like of the linked list, but you have to use it in terms of a stack mechanism. Now we will see which are the different operations possible with the linked list mechanism. Now we will see which are the different operations that can be handled while using the stack as a linked list. First operation is nothing but the create operation. Means you have to first of all create the stack. How to create stack? You have created the node of the stack, that is the struct node. Then you have to simply create the variable of it. Means what? Struct node star s. Okay. This is the node structure of the stack, and this is the variable representing the dynamic stack. Now we have to create a variable top to first of all at the null position, means top is empty. While implementing the stack representation using the arrays, we have used like top equals to -1 position, means it is empty. Now in terms of a dynamic mechanism, we are making it like top equals to null. Second operation is nothing